In this video, we're going to solve proportions. Now, we need to know something before we do that. We need to know something about ratios. A ratio is a comparison of two quantities by division. Two quantities, well, and it has to be some type of division thing. Well, the only thing that you know that looks like that is a fraction, like 3 over 4. So, why do they call these ratios? Well, because sometimes you have units attached to them. Like, for example, 3 cups. 3 cups of sugar over 4 eggs or something. So usually they have some type of units. Sometimes ratios can be also represented in a different way, something like 3 to 4, which is also a ratio, another way of expressing it. 3 to 4, 3 eggs to 4, 3 cups to 4 eggs. It also, another way, they represented something like 3 to 4, where they put a colon in between the two. Again, 2 and the colon represents some type of ratio, some comparison. Again, a fraction. Now, a proportion is something else. A proportion is a statement that two ratios are equal. Well, you've seen that before. For example, say 50 over 100. What is that equal to if you reduce it? Well, 50 goes into 50 once, and 50 goes into 100 how many times? That's right, 2. So half. So 50 over 100 is the same thing as saying, or is equivalent to half. So proportion is a statement that two ratios are equal, or two fractions are equal to each other. That's true. Okay, so I'm going to erase this. So let's do something like, here it is. Here's something like solve the proportion. Right, solve the proportion. And say something like 5 over 6 equals 15 over x. Okay, so how do we solve this? Well, we're going to have to do some cross multiplying. So here we go. 5 times x is 5x. Basically what we're doing is get rid of the fractions. 6 times 15, well, I don't know that. 15 times 6, 6 times 5 is what? 30, 6 times 1 is 6, 7, 8, 9, 90. There's an equal in the middle, so we put an equal in the middle, and then we put 90. Great. And then how do I solve for x? I got to get rid of this 5. How do I do that? Well, divide by 5, divide by 5, x equals, 5 goes into 90, probably around 18 times. Okay. And there it is. There's the answer. And you can see that 5 over 6 equals 15 over x. Well, x is what? 18. And you can see that you can reduce this fraction and you can get that, right? Because 3 goes into 15 how many times? That's right, 5. 3 goes into 18 6 times. So that's one way of thinking of it. But of course, these problems, they want to make them a little more difficult than that. So let's erase this. And we'll get rid of that here. So how about if you solve the proportion 2 over 3 divided by 5 equals x over 2. 2 over 3 divided by 5. You might think, well, think of it this way. 2/3 of a cup of sugar to 5 eggs. That's what they're talking about. The question is, how do you solve something like this? Well, there are different ways. There's about 3-4 ways you can do this. One way you can do it is, this fraction right here really looks complicated. So I'm going to write it out. Let's see. This says 2 divided by 3. And then you have this division here. Divide by 5. Sometimes you can remember how to do these. Here you have to say 2 over 3, and you have to change the division to multiply. And what do you do to the number to the right? That's right, you flip it over, and then 2 times 1 is 2, 3 times 5 is what, 15? Okay, so now this fraction has turned into that. And so what do we get? So we get 2 over 15 equals x over 2. And what do we do here? We cross multiply. 2 times 2 is 4. 15 times x is equal to 15x. And what do we need to do? We need to get rid of this 15. We divide by 15 on both sides. X equals 4 over 15. Okay, that's one way of doing it. Here's another way. 2 over 3 over 5 equals x over 2. So one way of doing this is, hey, sometimes instead of cross multiplying, there's another way of doing it. Like for example, I want to get rid of this 5, right? So I could multiply this on both sides 5. I'm not doing anything to the equation. I'm just multiplying both sides by 5 so that I can get rid of this denominator. That becomes 2 over 3. That's an equal sign. And here x times 5, because you can put a 1 here, x times 5 is going to be 5x. 2 times 1 is going to be 2. And you can see it's already building. Then I can technically cross multiply. Or you can do the same thing actually. You can multiply by 3 on both sides. But, you know, we're going to cross multiply here. 2 times 2 is 4. Don't forget the equal sign. 3 times 5x is 15x. And it just looks like this problem right here. Then divide by 15, divide by 15. And we also get x equals 4 over 15. Same answer. That's good. Then let's do one more. 2 over 3 over 5 equals x over 2. Another way is, pretend this fraction, right? Just think of it as one unit, one big thing. Okay, so what do? We cross multiply. Oh no, here we go. 2 over 3 times 2. 2 over 3, that's this fraction, times this 2. There's an equal sign. And then 5 times x, 5x. All right, let's clean this up right here. And we'll put a 1 here, so I know that that's a fraction as well. And then we go 2 times 2 is 4. 3 times 1 is going to be 3 equals 5x. 5x. So that looks kind of weird. Not a problem. 5x, you can put a 1 underneath. If you don't like that method, if you want to multiply by 3 on both sides, you can do that too. But I'm going to put a 1 over here. Now we got 4 times 1, 4. 3 times 5x, well, don't forget the equal sign. 3 times 5x is 15x. And then you got to get rid of this 15 by dividing both sides. And then what do we get? We get 4 over 15 equals x. Same answer. So all these are valid depending on the teacher. You know, sometimes some teachers want it one way or the other. This is more realistic of the problem that you're going to get probably on a test, because like the previous problem is just cross multiplying. They want to know if you can cross multiply with fractions, you know, these complicated fractions.